Let's go ahead and find the Taylor polynomial for this in two different ways. One is we'll take the derivative repeatedly, plug in 0. Well, we first substitute 0 into the function. That's going to be 0 times sine of 0. And now for the first derivative, we'll use the product rule, so the derivative of x, and then sine left alone, plus x left alone, and take the derivative of sine as cosine. And then if you substitute 0 into that, this is going to be 0, that's going to be 0, so we've got nothing so far. And then the second derivative, this would be cosine. And then here we need the product rule, so that's going to be plus another cosine. And then leave x alone and take the derivative of cosine, then that's negative sine. Okay, then substitute 0 into that. So this is going to be cosine of 0 is 1, another 1, and a 0. Then for the third derivative, so we've got two cosines here. Take the derivative of 2 cosines is going to be negative 2 sines. Once again, use the product rule. Well, if you notice here, I did the product rule and I got that. So I just need to apply this negative sign to it. So there would be negative sine of x and negative x cosine of x. And we get another big 0 out of that, because sine of 0 is 0. That's going to create a 0. No, we're not getting much out of this. Then for the fourth derivative, so this is negative 3 sines. If you take the derivative of that, it's negative 3 cosines. And here we need to use the product rule, so it's going to be negative cosine of x. And then leave the x alone and take the derivative of this as negative sine, so that's going to make it positive. And this is going to be, looks like a negative 4. So this right here makes negative 4, and this would be 0. Okay, so this would be the first term, and then this times x, and then this times x squared over 2. So we've got Taylor polynomial up to the 4th degree is going to be this times x squared over 2 factorial. And then this would be for x cubed, and this would be for x to the 4th, minus 4 x to the 4th over 4 factorial. When I said that too, I forgot to write it in front right here. And then I guess we could reduce it. This would be gone. We just have x squared. And this would leave, the 4's would cancel, leave 3 times 2 times 1. So let's see how good that Taylor polynomial is at estimating this function right here. So if we have x sine of x and compare that to x squared minus x is to the 4th over 6, and we're fairly close to 0, then what does it look like? So here goes x sine of x, and then the Taylor polynomial, not bad, considering it only has 2 little terms, an x squared and an x to the 4th, at least from there, negative 1.5 to about there. It's doing a very good job estimating that function. Well, the other way we could have done it is take a known series like the series for sine. Sine of x is equal to x, it's the odd numbers, then x to the 3 over 3 factorial plus x to the 5 over 5 factorial, etc. And then just multiply both sides by x. So then x sine of x can be represented by the series that goes x squared minus x to the 4th over 3 factorial plus x to the 6th over 5 factorial, etc. And then if we're talking about the 4th degree Taylor polynomial, then that is that, which is exactly what we got. Yay for us.